Section 2.2, Histograms, Frequency Polygons, and Ogives. Purpose of graphs in statistics is to convey data to viewers in a pictorial form. This is easier to comprehend the meaning when it is presented graphically. So we're going to be looking at the three most common graphs in research. The first one, histograms, then frequency polygons, and then the last one, cumulative frequency polygon, or otherwise known as ogive. The histogram is a graph that displays the data by using vertical bars of various heights to represent the frequencies of the classes. The class boundaries are represented on the horizontal axis. Turn your books now to page 57 and look at example 2.4. Construct a histogram to represent the data for the record high temperatures for each of the 50 states. Histograms use class boundaries and frequencies of the classes. We already created this frequency chart distribution in section 2.1. So this has already been done for you. As you can see, the class limits, but when you create that histogram, we're using the class boundaries and the frequencies. Notice on the x-axis, horizontal axis, are those class boundaries, and on the y-axis is the frequency. Pay attention to how the scale is created, counting by threes. And as you create the heights of the bars, they go up to how many are in that particular set. So since there were 2 in that first set, you're going to have a height of a bar of 2, and so on all the way through. The frequency polygon, on the other hand, is a graph that displays the data by using lines that connect the points plotted for the frequencies at the class midpoints. The frequencies are represented by the heights of the points. So on the x-axis will be those class midpoints. Now turn to page 58 in your textbook to look at an example there. Construct a frequency polygon to represent the data for the record high temperatures for each of the 50 states. Okay. Calculating out the midpoints from the class limits, just a reminder, that's taking 100 plus 104, then divide by 2, giving you 102. And continue with that process all the way through until you've gotten all of the class limits. This is the frequency polygon. Notice on the x-axis are those class midpoints, and on the y-axis is the frequency. So the midpoint of 102, and we put the number 2. Following the data. Then you can also see that to anchor the polygon, you go to the lowest class limit, which was 100, and you're going to place a dot there at the 0, and then the highest class limit was 134, so you put a dot here on the x-axis. The last type of graph is called the ogive. The ogive is a graph that represents the cumulative frequencies for the classes in a frequency distribution. The upper class boundaries are represented on the horizontal axis. The upper class boundaries are used since the cumulative frequencies represent the number of data up to the upper boundary of each class. Turn to page 58 in your book, or excuse me, 59. And it actually will continue on to the next page, 60. Construct an ogive to represent the data for the record high temperatures for each of the 50 states. Here's the information. Since the ogive uses the cumulative frequencies, you need to include that. And the class boundaries. So these are the two pieces of information you need. Class boundaries will go on the x-axis, cumulative frequencies will go on the y-axis. The lower bound will be the 0 cumulative frequency, and then it goes all the way up. As you can see, the points continue to get higher and higher. Hopefully that makes sense to you, because we are talking about a cumulative type of situation as each thing goes. Now, in terms of how to read this ogive, let's say, what does this point mean here? Okay, so you look down, it's a temperature of 119 and 5/10 degrees. So what this is saying is, you go up to this point and across, and this tells you there are 41 states that have a highest temperature of 119 and 5/10 degrees or smaller. Okay, so you're thinking all of these numbers here, all of those states here add up to this point. So the process for creating these statistical graphs, you need to draw and label the x and y axis. Choose a suitable scale for the frequencies or cumulative frequencies and label it on the y-axis. Do not label the y-axis with numbers in the cumulative frequency. Represent the class boundaries for the histogram or ogive, or the midpoint for the frequency polygon on the x-axis. So depending on which graph you're making will determine what you're going to put on the x-axis. Step 4, plot the points and then draw the bars or lines. If proportions are used instead of frequencies, the graphs are called relative frequency graphs. Relative frequency graphs are used when the proportion of data values that fall into a given class is more important than the actual number of data values that fall into the class. So this would be used if you want to compare two different populations and the numbers are drastically different. So for example, if you wanted to compare the population of small town in Iowa compared to the city of Des Moines. Those are very drastic populations, so you'll want to use relative frequency. Now turn your books to page 61 for an example of a graph. Construct a histogram, frequency polygon, and ogive using relative frequencies for the distribution of the miles that 20 random selected runners ran during a given week. So they gave you the class boundaries and the frequency. Then you need to do the calculations of the relative frequency. Again, that is calculated by taking the frequency in that class divided by the total number. Since there were a total of 20 runners, you're going to take 1 divided by 20 until you're all complete. When you add up the relative frequencies, they should add up to one whole. Now you can use the information to create that histogram. Notice on the x-axis are your class boundaries. On the y-axis now is the relative frequency, decimal values. So pay attention to what your highest relative frequency is and sort out your scale from there. The polygons need the class midpoints, so that was calculated by looking at the class boundaries, adding them up, and divide by 2. Again, class midpoints are on the x-axis, and the relative frequency on the y-axis. Ogive needs the cumulative relative frequency. So using the cumulative frequency, dividing by 20. You need the upper class boundaries and the cumulative frequencies to make the ogive. On the x-axis are the miles. Y-axis is your cumulative relative frequency. Notice the highest cumulative relative frequency should be a 1. Knowing the shape of a distribution can help you determine appropriate statistical methods to analyze that data. On this slide, you'll see that there are 4 different types of distributions. You have the bell-shaped distribution where you have a peak, one peak. Then you have the uniform distribution. This is flat or rectangular. J-shape. There is few data on the left and continues to increase as you move to the right. Inverse J-shape is the opposite of J-shape. They have a large amount of data on the left and then decreases as you move to the right. Some more shapes of distribution. Right skewed. The peak is to the left and the data taper off to the right. Okay. Sometimes this is also known as positively skewed. Then you have left skewed, and left skewed means you've got your data clustered to the right and it's tapered off to the left, and this is called negatively skewed. Bimodal means there are 2 peaks in the data, and U-shaped. Kind of see that U formation there. Being able to look at the shape of the curve can help you summarize what is going on with the data. At this time, this concludes section 2.2. Go ahead and go to Connect Math and continue working on those assignments. Thank you.